All right, let's get right into it. We're about to unpack a coordinated cyber attack that wasn't about stealing credit cards or data. No, this was about causing real physical chaos right in the dead of winter. This is the story of a digital assault on Poland's power grid. And hey, don't just take my word for it. That's a direct quote from CERT Polska, Poland's national cybersecurity team. They called it digital arson. And honestly, that term just perfectly captures the purely destructive goal we're about to see. I mean, the timing here just couldn't have been worse. It's December 29th, right before New Year's, and a cold snap is sweeping across Poland. And that's when a threat actor decides to launch a whole series of attacks, hitting renewable energy farms, a manufacturing company, and, most critically, a huge heat and power plant. So let's break this whole thing down into two main parts. First up, we're going to look at the attack on the green grid, the renewable energy sector. And what's wild here is how a pretty simple, almost crude method was able to cause such massive disruption. Yeah, we're not talking about one or two facilities getting hit. Nope. The attackers went after more than 30 wind and solar farms, all in a single day. The scale of it was just huge, which tells you this was a highly automated, sweeping attack built for maximum impact. Now, you gotta understand the objective here. The attackers weren't trying to immediately just flip the power off. Instead, their goal was to blind the operators. They wanted to cut all the communication links and make it totally impossible to remotely see or control what was happening at all these unmanned energy farms. And the playbook they used to do this? It's almost shockingly simple. First, they breached some weakly configured firewalls. Once they were inside the network, they started looking around for critical industrial devices. Then, they used the oldest trick in the book, trying default, factory-set passwords. And once they were in, they deployed their destructive code. And look, this was not some random smash and grab. They systematically went after the brain and the central nervous system of these facilities. They hit the remote terminal units. Those are the things that actually control the hardware. They hit the protection relays that stop dangerous faults. They even hit the computers that the operators used to see the system. They went after everything. So how was this all so easy for them? Well, it boils down to two huge security failures. First, and you're not going to believe this, default credentials. They literally logged into critical infrastructure using an account named Default. I'm not kidding. Second, a key security feature in the device software, one that's supposed to make sure updates are legit, was available, but it had never been turned on. The door was unlocked and the alarm system was off. And this right here, this shows you the arson in action. On the left, that's the code for the original healthy software. On the right is what the attacker uploaded. You see all those Fs? They just jammed a block of junk data right at the beginning of the file. So when the device tried to run this corrupted code, it would just immediately crash, get stuck in a reboot loop, and basically become a useless brick. And here's the smoking gun, the digital fingerprint. This is the event log from one of the fried devices. You can see it all play out. The attacker logs in using that default account. Then look at that highlighted line. At 13:57, firmware transferred to the device successfully. Just 1 minute later, the device is reset, and it never comes back online. The digital arson is complete. Okay, now for the second part of this story. Because while the attack on the renewable farms was loud and fast, the attack on the big combined heat and power plant was the total opposite. This was a quiet, patient espionage mission that had been going on for months. This timeline really shows you their patience. They first got inside between March and May, and then they just watched. They quietly started mapping out the network. Then in July, they made their big move. They stole the entire user database. At that point, they had everything. Every password, every permission. They literally owned the network. And only then, 6 months later, did they finally launch their destructive attack. So how in the world did they stay hidden for so long? By using tools that are already built into every Windows computer. This log here shows them using ping and NSLOOKUP. These are basic commands any network admin uses a dozen times a day. They were hiding in plain sight, just quietly mapping everything out, looking specifically for the industrial control systems. This right here, this is the moment they stole the crown jewels. This command sequence was used to copy and steal a single file. Think of this file as the master key card for the entire corporate network. It's got the password info for every single user and computer. Once they had this, they could pretend to be anyone, access anything, and no one would have a clue. So after all that planning, after months of sneaking around and stealing the keys to the kingdom, they launched their final destructive attack. And it was stopped. Despite everything, the attackers' ultimate goal of wiping out the power plant systems was actually thwarted at the very last second. So, how did they pull all this off? And what really connects these very different attacks? Let's open up the Saboteur's digital toolkit and take a look at the common weapons they used across the board. The primary weapon in all these incidents was something called wiper malware. And you have to understand, this isn't ransomware. They're not asking for money. It's not spyware. They're not trying to steal info long term. A wiper has one and only one job: to erase everything and make a computer permanently unusable. Pure digital arson. This slide really sums it up nicely. For the renewable farms, you had this wide, automated assault that exploited super simple passwords. For the power plant, you had a slow, targeted infiltration where they stole high-level credentials. But what was the common element, the one thread connecting all of it? Both attacks started by getting through the same type of network firewall. And this script just shows you how clever these attackers were. They left this behind on the firewall of a manufacturing company, and it was programmed to run every single week. Its job was simple: find the administrator password, copy it, and then send it to the attacker's private Slack channel. So even if the company changed their password, the attackers would automatically get the new one just a few days later. Okay, so let's pull back and look at the big picture here. Why does this one incident in Poland matter to all of us? Well, the answer is pretty simple. The line between a digital threat and a physical one, it's basically gone. This whole event was a perfect and frankly terrifying test case. It shows how a weakness in a regular office network, the information technology, or IT side, can be used as a bridge to attack the heavy industrial machinery, the operational technology, or OT side. A simple IT vulnerability, like a weak firewall password, became a direct path to attack the OT side and threaten a physical power plant. And the stakes here are just incredibly high. That power plant they targeted supplies heat to nearly 500,000 customers. Just imagine for a second if that final attack had actually worked. You'd have 500,000 people without heat during a winter cold snap. This isn't just about data, it's about public safety. So what are the big lessons here? First, critical infrastructure is a prime target. Second, the basics, like changing that default password, are absolutely non-negotiable. Third, determined attackers will play the long game. They'll hide for months if they have to. And finally, that power plant attack shows how crucial a last line of defense is. The day was saved by a tool that spotted the wiper's malicious behavior at the very last second and blocked it. Ultimately, this whole coordinated attack served as a massive warning shot. It was sophisticated, it was destructive, and in one case, it came terrifyingly close to succeeding. And it really leaves us all with a critical question to think about. Just how secure is the power grid, the water supply, and all the other critical infrastructure that we depend on every single day?